Hi everyone, this is Himanshu, and in this lecture we will read about the IRS satellite systems. IRS are basically the Indian remote sensing satellites. As we have already discussed that these are also called the Earth observation satellites. They are mostly polar, sun synchronous satellites in the low Earth orbit, which is at the distance of like 800 kilometers from the Earth's surface. Apart from that, they zip around the circumference of the Earth in 1.5 hours. In a circular orbit, the few hundred kilometers above the surface, the velocity of the satellite must be about 8 km per second before they are put into the polar orbit. So they are commonly called the remote sensing satellite as they collect information of any object on Earth through the measurement of radiations of the sun that is reflected and scattered by object on the surface of the Earth. So if you read about its applications are diversified in the field uh, of the natural resource management. It can be in the land use assessments, mapping, mineral prospecting, forest surveys, etc. It can also be used for the agriculture and in the assessment of the net crop area, crop production, the damage assessments, in classification of the agroclimatic zone. So that was actually important in classification of agroclimatic zones. We generally use the IRS 1A and IRS 1B. Yes, apart from that, they can be used for the meteorology itself, in the early warning mechanism for cyclones, weather forecasting, monitoring for droughts and floods, and the urban studies, which include the study of the urban sprawl, the traffic management, etc. And you can say that it is also used for the defense mechanisms, defense purposes. So some of the important remote sensing satellites like ResourceSat is one of them, the Kratosat, the ReSat, OceanSat, ScatSat. We have already discussed most of these. So let's go one by one and study about the important satellites in this field. So the first one we're gonna discuss is the recent remote sensing satellite, which is basically the ReSat, RISAT 2B R1. This was pretty much in news recently. So the ReSat 2BR is a radar imaging. So RI itself means that it is radar imaging Earth observation satellite in the ReSat series, and the radio imaging satellite with X-band. So the synthetic aperture radar which enable all weather day-night radio communication. So we can write this thing as it has a synthetic aperture which enable it to provide the all-weather day-night radio communication. More importantly, it has the radius of less than 1 meter of the lens, and I don't think that's pretty much important. Apart from that, it is equipped with the unfurlable. So this is a bit complicated word, but if you understand the meaning of this word, it will be quite easy. This is called the unfurlable radial rib antenna technology. Now, a quite complicated word, but originally it actually means that if this is a point A, now if a signal is received by this A, what A will do, A will receive the signal, it will modify them, and it will retransmit back the same signal again, a modified one. So the A is basically called the unfurlable radial rib antenna technology. So this is what it actually means. It receives, modifies, and transmits back. So this is basically how they are receiving, and the communication has been done in the RISAT satellites. So the applications are pretty much forward, like agriculture, forestry, and disaster management. Similar to this one, there is also the RISAT 2B. We can mention it here. There is RISAT 2B, which is basically used for the both India's, the post India surveillance yes, that is the main function of the RISAT. And if you're gonna ask me that what does a remote sensing actually mean, so I'll explain you the very layman terms again so that it is quite understood. So if we say a remote sensing, it can be of two types. The first one is optical remote sensing, and another one is the radar imaging remote sensing. In the optical remote sensing, what generally happens that it uses light which is reflected by object on Earth's surface to sense and observe, whereas in the radar imaging it will use the radio imaging, basically a radio signal on the Earth's surface, and senses the radio signal reflected back. So it uses here the radio signal. So if this is Earth, now an optical RS, the amount of light which is here and reflected back, it will study this reflected back one. So example, if this is B is a reflected one, so the B will be studied and observed. Similarly here, if this is a surface and this is reflected back, here the B is basically radio signal which will be observed. Now the interesting point here is that those satellites which actually work on the optical remote sensing, they are functional only in the light, means it can only be used in the daylight, it cannot be used in the night time, right? Even if there is a cloud cover, even if there is a rain, the light won't reach to the Earth's surface, so it cannot be studied. So it has a limited usage because it cannot be used in the daytime. Apart from that, the radar imaging, a remote sensing satellite, it can be used both in the day and the night, even if there are cloud cover or the rain. So this one is much better. So that's why the RISAT, having a radar imaging satellite, can also the sense during the cloud cover or the rain itself in the night time. So this is mainly about the RISAT satellites. Now let's jump to the next one, that is the third, Cartosat. Three. Now the Cartosat itself, the name the says, it is basically regarding the cartography. Now the third generation agile advance, it basically a height of the 509 kilometers, because as I told you that the IRS satellite are only at the height of the LEOs, so that they are only then they can observe the Earth in a better perspective. So the cartography satellites, these are also at the range of the 800 and 600 kilometers, and it has one thing that's important, that is a panchromatic resolution. So you can remember this word, that it uses a panchromatic resolution, and which is of 25 centimeter, and at present this one is actually highest in the world. So the mode application of the cartography is basically like a large-scale urban planning, the rural resource infrastructure development, land information system, the geographical information system, coastal land use, various of them. And I think that you are well capable in finding the application of your own regarding these things. So that's easy. The next satellite that we're going to talk about is the GiSAT. GiSAT means GI-SAT. So I would say GI-SAT, it would be better, because GI-SAT actually means that it is a Geo Imaging satellite series. Geo Imaging satellites, right? Now, this one is the only one which this is only IRS satellite which is not placed in the LEO. It has been placed in the geosynchronous orbit at the height of 36,000 kilometers. Now, that's why this is important. It has the multispectral and the multi-resolution. Multi-resolution, that is the 50-meter aperture, and that because of this thing, it make possible to images read in the visible, near infrared, and the thermal spectrum. So it works in all these three ranges because of the multispectral and the multi-resolution camera, or you can say a lens. So this is pretty much good. Apart from that, it is used for the both military as well as civilian. So let me write it here, that here as a note, that both military and civilian. Apart from that, the significance, as I already told you, that it is different from the rest IRS because it is not placed in the LEO. Now you're gonna ask me a question that Himanshu, why the few satellites have been placed in the LEO and why the few are placed in the GEO, despite of the fact they are both are IRS. Now the only point is that if suppose this is Earth, now here if one particular satellite is here and this is basically what we call as a LEO. Now if there is another satellite which is placed in the geosynchronous orbit, suppose here, the only difference between is that when a particular satellite is in the LEO, only a particular area is covered by this satellite. That is the only problem. And to be in this position again, it takes a delay of 22 days. But however, if it is in the GEO, so let me write it here as a LEO, this is a GEO. Now if we are at the GEO, our area will increase proportionately, and apart from that, whether in the LEO it take 22 days, but in the GEO it will take only 2 days to be at the same position again. So that is why it is advantageous to place a satellite to the GEO. But at the same time, this is a costly, actually it requires more amount of payload, the heavier rockets are used and good amount of technology is required for this thing. So that's why we have placed the GiSAT in the GEO. So that is a main a point that you need to remember. Then the next satellite that we're going to talk about is HYSIS. HYSIS, that is basically the Hyperspectral Imaging Satellite. Now this is the India's first, that's very important because India's first hyperspectral imaging satellite. Apart from that, it has been placed into the sun synchronous polar orbit in the LEO itself, again, right? Or yes, right? And it is again can go through the three different ranges of the visible, near infrared, and the short wave. And it is pretty much similar if I explain you that, like the CAT scan you do of a body, so similarly it will provide a CAT scan of the Earth itself. So it's equivalent to that. Nothing much important in this thing. Apart from that, it is used in agriculture, forestry, coastal zone, inland, soil, oil, minerals, military surveillance, similar like that. Plenty of them. Now, the only thing is that a word that need to be noted is a hyperspectral. Now, Hyperspectral actually means a combination of both digital imaging plus spectroscopy. And to make this both work together, a chip is usually used, which we call as a critical chip. And this critical chip is called the optical imaging detector array. Detector array. So this is what it means. Now you're gonna ask me that digital imaging in spectroscopy, what does it actually means? Just imagine that when an electromagnetic wave shines on the surface of an object, the some wavelengths are absorbed while others are reflected back. And this is how we observe light. For example, if this is an object, so here suppose an electromagnetic wave make a strike here, and this is 100% of it. Now it will reflect back 60%, whereas the 40% of it will be absorbed here, right? Now on the basis of this 60%, it will define the characteristic of that particular object. So for example, a leaf, you know for example, how can I, yes, the color of the plant of the leaf. So what happens generally, the color of the plant of the leaf is green because it absorbs the red and the violet light, but it reflects the green light, which is what we see as a color green. So this is what basically the spectroscopy means, and this is what we call the spectral signature. So here this thing is what we call as spectral signature, what is reflected back, right? So this is mainly about the spectroscopy and what the hyperspectral means. And apart from that, the other satellite that we're gonna discuss about are the Indian regional satellites, or IRNSS, and we will cover the IRNSS in the next lecture. Thank you.